Hey guys, Professor Floyd here, and we are doing OEH 5723, homework 8, number 3. So this was the question where I told you that you work at a manufacturing facility where you typically use mild steel that's welded and torch cut on a routine basis, but a client has ordered a large batch of product to be fabricated out of stainless steel, 316 stainless steel. You weren't consulted about this. You know, management got a job. They're glad to keep the factory busy for another 3 months. And so this big order comes in, and you conduct welding monitoring, every quarter or something like that. You're doing a good job with routine monitoring. So you go out, you collect your routine monitoring, full shift samples over the course of a week, and you just choose one guy on one day, one guy another day, and you spread it out. And when you get the results back, you have lower iron than you usually have, and you have nickel and chrome levels way higher than you've ever seen before. And so I tell you what these nickel and chrome levels are, and you have 5 measurements. And so you go out and you start trying to figure out why you have high levels of nickel and chrome. So my first question is this reasonable? Do you expect higher levels of nickel and chrome now that you know that they're using stainless steel? So yes, you should expect higher levels of nickel and chrome because this is stainless steel, not mild steel. Mild steel should be virtually nothing but iron and a little bit of carbon. But stainless steel is going to be mostly iron, a fair amount of nickel, and a fair amount of chrome. If you get online, you can look up the exact blend of 316 stainless steel. I don't have that data in front of me, but it should be a standard blend because it gives it a certain chemical resistivity and rust resistivity and whatever else. So you shouldn't be surprised. Now that you know that your company is using stainless steel, you should go raise Cain with your boss for not having consulted you on that, just because your employees are being exposed to nickel and chrome now, and you should have been aware of it. So I'm asking you, what is the 95th percentile level of nickel and chrome based on the results? And I'm telling you, use a log normal approach. So you have 5 data points for nickel and chrome, and I'm not going to work this out. I'll give you the answers so that you can check your work, but I'm not going to do all this on the board. But you have nickel, and then you have chrome, and you have data point x1, x2, x3, x4, x5, or nickel 1, 2, 3, 4, and 5. And these were collected on different days. They are collected on different workers. So they don't represent a normal distribution. They are, in all likelihood, a log normally distributed set of data. So if you're going to try to determine what's the central tendency on this, then you need to find out what the geometric mean of these exposures is. The way you do that is you convert these concentrations into log. You just take the log of each concentration and then take the average of those log transforms. And that will be your geometric mean. Well, and then you de-transform that value. So first, you'll have your ln of nickel, and so it'll just be ln x5. Oh, did I lose my? No, we're still videoing. I don't know what that was. So you can then find what the average of your log values is, and so you'll get some number, and let's say it's ln x bar. It's the average log, and then you just take the de-transform this e to the ln x bar. Right. So de-transform it and take the anti-natural log of it, or anti-log, whichever way you choose to log convert these, and you'll get a number, and that's your geometric mean. So let's see. I've got the value for each of these. The geometric mean did I calculate that? Yeah. No, I gave your 95th percentile. Well, that's... Oops. I should try to do formulas while I'm equals exp of this. Okay, so the geometric mean for the nickel data should be 0.02. So gem nickel is 0.02 milligrams per cubic meter. And then the geometric mean for chrome should be let me just make sure that that's right. Yeah, it should be 0.03. Milligrams per cubic meter. Okay, now you've got to interpret this data. So is this of, well, all right, now I ask you, what is the 95th percentile? So you have an average. You can also calculate your standard deviation of these logs, standard deviation of your logs, and your 95th percentile is going to be just like we did on the previous one. It's going to be your mean plus 1.645 standard errors. And standard error is standard deviation divided by square root of n. So we have 5 samples, and we calculate our standard deviation of our means. And so if this is all in log transform data, then this is going to be your average of your logs, and this is going to be your standard deviation of your logs, and you'll get some number that's going to be a log transformed number. And so it's going to equal, we'll just call it x95 log. And so you take e to the x95 log. And whatever that number is, that's your 95th percentile. And so I've calculated that. And we find that our 95th percentile, make sure I'm referencing the right thing here. Yeah. For nickel, .95 percentile nickel is 0.027. And our 95% chrome is 0.042. And these are all milligrams per cubic meter. Okay. So then I ask you, based off of these results, what conclusions can you draw? So, if you're going to draw a conclusion, you have to know what to compare this against. So you had to get online, you had to look up the exposure limits for nickel, chrome, and if you're thinking about it, hex chrome. If you looked into whether stainless steel was a bad deal or whatever, you should have found that hex chrome is something to be concerned about. And so that's going to be chromium in the 6+ valent state, and it's water soluble, and then it can get into your body and it can start to cause cancer eventually. So the movie Aaron Brockovich was all about like chromic acid or hexchrome exposure out in California. So the OSHA PEL for nickel and chrome, just elemental, is 1 milligram per cubic meter each, but for hexchrome is 0.05 milligrams per cubic meter, so 5 micrograms per cubic meter. So the NIOSH REL is for nickel 0.015, for chrome 0.15, and for hexchrome 0.0002 or 0.2 micrograms per cubic meter. And then the ACGIH is 1.5, 0.05, and 0.05 for hexchrome. So it's nickel, chrome, hexchrome. So you would also notice that there's some TLVs for insoluble nickel and insoluble chrome or hex chrome. And so, what do you do about that? You're not exactly sure. Unless you're a chemist, you probably don't know. So you should look that up and reference it. I wasn't trying to get you into that. I just wanted you to see that sometimes it's not straightforward when you try to interpret, when you try to find what's the limit that you're going to compare against. So you have nickel and you have chrome data. Based off of all of these levels, so the nickel TLV is, the nickel PEL is 1 and the chrome PEL is 1. So you're fine. You have no worry that your geometric mean is going to exceed or that your 95th percentile is over the limit. However, for the NIOSH limit, for nickel, you are at 0.027 and they say 0.015 for nickel. So you would be concerned that this type of exposure distribution is going to be overexposing your employees. I mean, you had 5 measurements, and of those 5 measurements, you saw that your 95th percentile is going to be greater than the recommended exposure limit. And for chrome, it's 0.5, so you're fine here. You look at, however, what you should then be thinking about for the chrome is that what if all that chrome is actually hex chrome? It shouldn't be, but you don't know because you didn't measure it. And that's one thing you would have been measuring if your boss had told you that they were going to switch to stainless steel. You would have set up, you would have included these, and then you also would have specifically monitored for hex chrome and had it analyzed by ion chromatography or some sort of colorimetric detection with complexing and then analysis by UV-vis absorption. And so at 0.042 milligrams per cubic meter, this blows all of the values out of the water, except for the ACGIH TLV, which is still, at least when I looked it up in the 2009 or 2010 TLV book, is still 0.05. So you're going to greatly exceed that for OSHA by almost a factor of 10 and by a factor of about 20 or 30, 25 for about 20 for NIOSH. So if this was all hex chrome, you'd have a problem. The last question I asked you is there anything further, any further data you need to determine if your welders are being overexposed to nickel or chrome? And I left that generic because I was hoping that you would recognize that yes, you need to look out for hex chrome. And so what you would need is to monitor for hex chrome. So you would specifically want to look that up, and I believe it's NIOSH method 7300 is specific for hex chrome. So if you don't use a method that's specific for hex chrome, you're kind of obligated to assume that all of that chrome is hex chrome. It's probably not. It's probably only like 1 or 2% of that is hex chrome. But you have to assume that since you don't know. And then when you find out, then you can change your risk paradigm and your assessment. So, I'm sorry, it's NIOSH method 7600 that would be applicable for hex chrome specifically. So, yep, that's all I've got to say on that.